And what we can see here is what we pick up in the background. The access to the tasks, both for the collaborative problem solving and for the ICT learning and networks, is via just a web-based browser. So typically we use Internet Explorer or Mozilla Firefox. And with the collaborative problem solving tasks, we always have two students who are working together, and those two students are linked by a team code. So in terms of us working across each of the countries, each country receives sets of logins and team codes so that they can actually collect the data for the trial. Each of the environments, whether it's for collaborative problem solving or ICT learning, has a chat box so the students can interact, and they love that. So it's immediately they hear, oh, it's just like Messenger. That's fine. They understand that they can use that chat box to communicate and to work out where they're going. They all have navigation buttons, and several of the tasks in each of the skills area have multiple pages and multiple problems. So again, it's not like a typical classroom-based recall of memory task. These are tasks where the students are required to explore. As we move on to the next slide, you'll see what we're going to be picking up in the background here. And what that is that we need to code all of the information that we're collecting. So we're collecting data from multiple streams. We have two major streams of data that come in. One is what we've referred to here as a process stream. So as the students move through the tasks, they make selections, they move their mouse around the screen, they click on things, they explore. All of those particular activities are collected and sent through. We also collect the actual data that students enter, so this might be numbers or operatives or words. At another level, we collect the chat stream, so what it is that each student puts into this input message box, and then the transcript of what happens outside of that. So we are able to code both the presence of chat as well as the use of keywords. So all of these data sources go toward our scoring. Through to the next slide, we can see that the process and the chat data can be coded back to the elements of, in this case, collaborative problem solving. So what we have in the first column here is a set of the actual process data. So we can see when the student entered the session, we can see what the IP address of the student was, which also tells us, of course, what nation or country they're in. Or mostly it does anyway, and we also have a unique identifier for the particular student. And so all of these bits of process data are coded. We can see further down here that for this particular task, which is one where students need to place cameras to cover particular areas, that we can see how they place the cameras. So we can check how systematic students are as they go through particular parts of problems. We can also here see some of the chat stream. And so we've got here student B is saying, how does this work? And we can code this to a particular element of the matrix that we have that describes collaborative problem solving. Task regulation is part of the mapping out of problem space, for example. And here we have A saying, I think the first camera should be there because you can see down the row. So the student is starting to build relationships between parts of pieces of information, and it's also communicating that. So as we look through the chat, we can also see how that relates to the particular area of skill. So all of this stuff is happening in the background, and what's happening at the country level on the next slide, we can see in terms of organisation of how the tasks are given across the different countries. So here we can see some of the materials that are sent out to the NPMs, the National Project Managers in each of the countries. And we can see that particular tasks that we have here take different amounts of time. And according to suitability across different age ranges, 11, 13 and 15, we look at how these tasks can be bundled nicely to ensure both a counterbalance design so that we can check how students operate across the different tasks, and we can also see how students at different year levels can cope with the tasks. Down here in Table 2, we have a little piece of information that gives an idea of how teachers in classrooms should set up the two sessions. So for each, in the trials in each country, each class of students initially for the collaborative problem solving is doing 2 sessions, and the same for the ICT, literacy, learning and networks, 2 sessions each. So we have a startup practice task, then we might have a couple of the particular tasks that are put into bundles, and then we have a peer and self-rating questionnaire. The peer and self-rating questionnaire is an excellent addition to what we're doing. It requires students to think about how they've gone through their task with their partner and to rate themselves and to rate their peer about that. And quite apart from the questionnaire providing another source of data for us, what it does is it acts as a really good prelude for the students themselves for debriefing after the tasks, and also it's been leading into a great precursor for teaching and learning ideas for the teachers in the classrooms. So we'll move on now to looking at the particular countries again in terms of how they've actually implemented this set of activities. So again, I'm here talking from Australia, and of course we have Kathy Comfort coming in from the USA, and then Maria Eugenia coming in from Costa Rica. Thank you. Over to you, Kathy.